There is a machine in a basement in Boulder, Colorado. It does nothing but count. It counts the vibrations of cesium atoms. Over 9 billion oscillations every single second. This machine would not lose 1 second in 300 million years. It is the most precise timekeeper ever built by human hands. On June 29, 2022, this machine detected something. The Earth finished its rotation 1.59 milliseconds too early. Not hours, not minutes, and not even a full second. A sliver of time so thin your brain cannot register it. But to this machine, a millisecond is a scream. That day lasted 23 hours, 59 minutes, and 59.99841 seconds. The shortest day in recorded atomic history. And it was not a glitch. It was the continuation of something that started in 2020. The planet is spinning faster than at any point in half a century of atomic timekeeping. But what happens when a world that has been slowing down for 4.5 billion years suddenly starts speeding up? The moon has been pulling the brakes on Earth's rotation since the beginning. Our days have stretched from 6 hours to 24 hours over deep time. The deceleration is ancient. It is constant. It is massive. And something is now overpowering it. Something hidden in the darkness beneath your feet. Something melting at the poles. Something pumped from the ground by human hands. If you enjoy what comes next, a gentle tap on like and subscribe means more than you know. We begin now. You think you know what a day is. 24 hours, midnight to midnight, a number on a clock, a unit of time as fixed as the inch or the kilogram, something agreed upon by committees and printed in textbooks. That is not what a day is. A day is the actual, physical duration of one complete rotation of the Earth, not a convention, not an abstraction, not a human agreement. It is a measurement of something real, a spinning mass of rock and iron and water and air turning once on its axis. And that measurement changes. It has always changed. It will never stop changing. The length of a day is a running total, a ledger. Every force acting on this planet either adds to the spin or subtracts from it. Every shift of mass, every current of molten metal, every glacier that cracks and slides into the sea. And the ledger records all of it. And the atomic clock in that basement is the accountant that never sleeps. Here is what most people assume. They assume that when someone says a day is 24 hours, they mean it exactly. They imagine a day as a perfect mathematical constant, a circle divided into equal slices, something reliable, something settled. No 2 days in Earth's history have been precisely the same length. Not one, not ever. Every single rotation since this planet formed has been slightly different from the one before it. The 24-hour day is a human averaging of a constantly fluctuating reality, a rounding, a simplification. The universe does not deal in round numbers. Actually, let me be more precise. When I say a day is getting shorter, I do not mean you will notice. You will not. Your body cannot detect a millisecond, but the machines can. And what they are detecting is not noise. It is signal. Yeah, the day you woke up to this morning was not the same length as the day before it, and both were different from every day your ancestors ever lived through. Your great-grandparents lived through days that were measurably, detectably longer than yours. Not by much, a few thousandths of a second. But the ledger does not forget. Think of the Earth's rotation as a bank account. Deposits and withdrawals happen in milliseconds. Every force acting on the planet either adds to the balance or takes from it. The spin is the total. And right now, something has been making deposits. In the 1960s, scientists began measuring the day with atomic precision for the first time. They established a baseline. They watched. They recorded. For decades, the pattern held. The planet was slowing down, just as physics predicted. Small variations, but always trending in the same direction. The ledger was consistent. And then came 2020. The planet spun faster that year than in any year since measurements began. The trend reversed. The accountant noticed. 2021 came. The planet broke its own record. The days grew shorter again. The ledger updated. 2022 arrived. Another record. Another entry. The gap between what the clock expects and what the planet delivers is widening. Not by much. Not by anything your body can perceive. But the machines see it. And the machines see everything. A day is not a number. It is a living measurement. A heartbeat of a spinning world that changes with every shift in mass, every flow of iron, every melting glacier. The ground beneath your feet is spinning at a speed that has never been constant. And right now, it is accelerating. This ledger has been keeping records for 4.5 billion years. Every collision, every volcanic eruption, every asteroid impact, every slow drift of continents across the surface, all of it written in the rotation, all of it encoded in the length of a single day. The rotation remembers what the surface forgets. Mountains rise and erode. Oceans open and close. Species emerge and vanish. But the spin carries the memory of all of it. A day is not just a measurement of time. It is a measurement of history. Something changed in that record recently. The ledger that has been tracking a slow, steady deceleration for eons suddenly began tracking acceleration instead. The signature shifted. The pattern broke. The question is not whether something is acting on the planet. Something is always acting on the planet. The question is, what force is strong enough to reverse a trend that has held for longer than life has existed? The ledger knows. It has been recording the answer in milliseconds. Day after day, rotation after rotation, the atomic clock reads the entries. Yet the entries are getting stranger. 4.5 billion years of records, billions of rotations. And somewhere in the recent pages, a new handwriting appeared. The ledger is a running total. It has been keeping score since the beginning. And if a day is not a fixed number, but a living measurement, then something has been writing in that ledger for a very long time. What has been making those entries? But what ancient forces have been shaping the length of every day since the Earth began to spin? The answer starts deeper than you can imagine. The answer starts with violence. 4.5 billion years ago, the solar system was a shooting gallery. Planets were still forming. Debris filled the space between them. Collisions were not rare. They were constant. Earth was young then, barely cooled. A molten ball of rock and iron with no moon, no oceans, no life. And just heat and chaos and the slow pull of gravity shaping something new. Then, something hit it. Astronomers call it Theia, a world the size of Mars. It came in fast, at an angle, and struck the young Earth with enough force to liquefy both bodies. The impact was so violent that pieces of both worlds were thrown into orbit. Rock and iron and molten debris sprayed outward in a ring around the wounded planet. From that ring, the moon was born. The collision did something else. It set Earth spinning, fast. In those early days, before the oceans existed, before the continents formed, a single day lasted only 6 hours. The planet completed 4 full rotations in the time it now takes to complete one. Everything moved faster. The sky wheeled overhead. The stars traced their arcs in hours, not throughout a night. But the moon was watching. It hung in the sky, much closer than it is today, close enough to fill a quarter of the horizon, close enough to pull. And pull it did. From the moment it formed, the moon's gravity began reaching toward the spinning Earth. Here is what happened next. The moon's gravity raised bulges in the Earth, not just in the oceans, in the rock itself. These bulges are invisible to your eye, but they are real. They rise on the side of the Earth facing the moon, and on the side facing away. 2 bulges, always present, always tracking the moon's position. As the Earth rotates beneath them, yet these bulges drag against the spin. They create friction. Picture 2 handles made of water and stone, gripped by the moon, pulling against every rotation. Invisible handles, relentless handles, working against the spin for billions of years without rest. This is tidal breaking. Every rotation, the moon steals a tiny amount of energy from the Earth. Not much, not anything you could measure in a human lifetime. But the moon does not operate on human timescales. And that stolen energy has to go somewhere. It goes into the moon's orbit. Every year, The moon drifts a little farther away, 3.8 centimeters. That is roughly the speed your fingernails grow, imperceptible, meaningless on any scale you can experience directly. But add it up over millions of years, over hundreds of millions, over billions. The moon that once hung so close it dominated the sky has drifted to a distance of 239,000 miles. And that much empty space, accumulated centimeter by centimeter, nail growth by nail growth, across an abyss of time so vast that life did not exist when it began. And as the moon recedes, Earth slows. This is not theory, this is physics. The same physics that governs every spinning object losing energy to friction. A top slows down, a wheel eventually stops, and a planet, dragging its tidal bulges through space, surrenders its rotation to the patient pull of its own satellite. And the record is written in stone. Literally, ancient rocks contain growth rings, like trees, coral fossils, tidal sediments, layers that mark the passage of days. Scientists have counted these rings, measured their spacing, and reconstructed the length of days in deep time. When the first single-celled life appeared on Earth, a day lasted roughly 16 hours. Life began on a faster planet. Cells divided, organisms emerged, and the world spun through shorter days than any creature alive today has ever experienced. When dinosaurs walked the Earth, a day had stretched to roughly 23 hours. The great reptiles lived and died on a planet that was still faster than ours, still slowing, still surrendering energy to the moon. The current 24-hour day is not permanent. It is a snapshot, and a single frame in a movie that has been playing for 4.5 billion years and will continue playing for billions more. The direction has always been the same. Slower, longer, steadier, until now. The tidal break has not failed. The moon is still receding. The bulges are still dragging. The friction is still stealing energy from every rotation. Nothing has changed in the mechanics that have governed this planet since the violence that created both worlds. Yet the planet is speeding up. Consider what that means. A force that has been winning for longer than continents have existed is suddenly losing. The ancient break, applied without interruption since the first day, is being overpowered by something else. If this process had continued uninterrupted, scientists know what would have happened. Billions of years from now, Earth would have become tidally locked to the moon, one side always facing it, one side always turned away. A day would equal a month. The rotation would effectively stop. The break would win. That future is being disrupted. Something on this planet, something happening right now, is stronger than the grip the moon has held for 4.5 billion years. Something is adding energy to the spin faster than the tidal bulges can drain it away. The ancient brake is still applied. It has never released. But something else is pressing the accelerator. The moon should be winning. Now, for 4.5 billion years, it has been winning. Every rotation, every tide, every single day since the violence that created both worlds. The brake has never released. The friction has never paused. The slow, patient theft of momentum has continued without interruption across an expanse of time that dwarfs everything humanity has ever known or will ever know. And yet, something changed. Something broke the pattern. So the force that has dominated this planet since before rock existed in its current form is suddenly, impossibly, being overpowered. To understand how strange this is, consider a top, a child's toy, struck once and left to spin. The moment it begins rotating, it begins dying. Friction steals energy from every revolution. Air resistance drags at every surface. The spin slows. It wobbles. Eventually, it falls. That is Earth. A top struck 4.5 billion years ago by a collision so violent, it liquefied the surface and tore away enough material to form the moon. The planet has been spinning ever since, and slowing ever since. The outcome was never in doubt. The top would eventually stop. Except now, someone is kicking the top while it spins. Fresh energy is entering the system. Not from outside, from within. Something on this planet is adding rotational force faster than the ancient brake can remove it, and the top should be winding down. Instead, it is speeding up. In 1972, the world agreed on a solution to a problem most people never knew existed. Earth's rotation is not perfectly stable. It drifts. It varies. Days are not always exactly the same length, so the international timekeeping community created a tool called the leap second. The concept is simple. When the planet falls far enough behind atomic time, we add a second to our clocks. We pause the count at midnight and let the Earth catch up and continue. Since 1972, this has happened 27 times. 27 seconds added to human time. 27 tiny corrections, each one an acknowledgement that the planet is slowing, that the moon is winning, that the future we expected, a future of longer and longer days, was inevitable. The assumption built into every one of those 27 decisions was this: we would always be adding time, never subtracting. The brake was eternal. The direction was fixed. The only question was how often we would need to make the adjustment. No one built systems to handle the opposite case. Think about what a leap second touches. Every satellite orbiting overhead, every financial trade executed on a global market, every power grid synchronizing its frequency to atomic clocks, every flight path calculated by air traffic control, every packet of data routed across the internet. All of it depends on knowing exactly what time it is. And all of it was built on the assumption that time moves in one direction, forward, with occasional pauses to let the slowing Earth catch up. The metronome civilization was built on has started skipping beats. Here is what almost no one knows. We may need to subtract a second, not add. Subtract. A negative leap second. Remove a beat from the rhythm of human time because the planet is running too fast. This has never been done. In the entire history of coordinated universal time, no second has ever been deleted. The systems were not designed for it. The software was not written for it. The protocols do not anticipate it. Computer scientists have studied this possibility, and their assessments are blunt. A negative leap second would stress every time-dependent system on Earth. Bugs that have never been triggered would activate. Errors that exist only in theory would become real. And the infrastructure of modern civilization would be subjected to a test it was never meant to face. All because the planet is spinning slightly too fast. We built our world on bedrock we assumed was stable. We synchronized our systems to a rhythm we believed was slowing. We constructed the most precise timekeeping infrastructure in human history, and we anchored it to a planet we thought we understood. The planet is doing something it should not be able to do. Consider the forces at play. On one side, the moon, pulling at the oceans, dragging at the crust, stealing momentum with every rotation for longer than life has existed. A force so constant, so patient, so relentless, that it has shaped the evolution of every creature that has ever lived on this world. On the other side, something else, something operating right now, something powerful enough to overpower an effect that has dominated the planet for 4.5 billion years. And that is not a small shift. That is not a minor fluctuation. That is a tug of war between forces operating on fundamentally different scales, and the underdog is currently winning. The timeline is almost impossible to process. 4.5 billion years of deceleration. That is 900 times longer than the entire existence of complex life. It is more than 1,000 times longer than the age of dinosaurs. It is roughly 20 million times longer than modern humans have existed. And then, in roughly a decade, the pattern reversed. Whatever is accelerating the planet began asserting itself around 2020. That is 5 years. In the context of geological time, 5 years is not even a rounding error. It is not even a flicker. It is the blink of an eye of a creature whose lifespan is measured in billions of years. Something that took 4.5 billion years to establish is being undone in the span of a human childhood. Yet the leap second crisis is not about 1 second. It is about what that second represents. A planet that was supposed to be predictable is no longer behaving predictably. A rhythm that was supposed to be stable has become erratic. A foundation that was supposed to be solid is shifting beneath our feet. We are not observers of this change. We are participants in it. Whatever is accelerating the Earth is not some distant phenomenon occurring in the vacuum of space. It is happening here, on this world, in this era. While you listen to these words, the machines that measure time have become sensitive enough to detect planetary instability. The clocks in Boulder, the atomic standards around the world, the satellites in orbit, all of them are recording something that defies the dominant pattern of this planet's entire existence. The top should be slowing. The friction should be winning. The outcome should be predetermined. But the top is speeding up. Their fresh kicks are being delivered to a system that should be winding down. And the source of those kicks is not external. It is not an asteroid strike or a solar flare or some cosmic intervention. It is coming from inside the planet, somewhere beneath the surface, or on the surface, or in the shifting weight of water and ice and air. Something is adding energy to the spin, something powerful enough to register on instruments designed to measure the vibrations of individual atoms. Something that announced itself in the data around 2020 and has not stopped since. The moon has been applying its brake since the beginning. It will continue applying that brake for billions of years into the future. The physics has not changed. The mechanics remain the same, but the outcome is no longer certain. What forces could possibly be strong enough to overpower the grip the moon has held since the first day? Or what processes could be adding rotational energy to a system that has been losing it since before continents formed? What is happening to this planet that has never happened before in all its long history? The answers lie somewhere in the machinery of the Earth itself, in the liquid iron miles below your feet, in the ice fields at the poles, in the weight of the atmosphere pressing down on every surface. Yet in the water, humanity has pulled from underground aquifers and dammed behind concrete walls. The planet is a system of interlocking forces, and somewhere in that system, something has shifted. The search begins in the only direction it can, straight down, not down into data or theory or speculation, down through rock, down through pressure, down through heat that would vaporize anything we have ever built. The source of the disturbance is not on the surface. It is not in the sky. It is buried beneath 2,000 miles of stone and darkness. 2,000 miles. And that number deserves a moment. The distance from New York to Denver is roughly that far. You could drive it in 30 hours, watch the landscape transform from coastal marshes to mountain peaks. But this journey goes through no landscape at all. It goes through the interior of a world that has never seen light, never felt wind, never known anything but crushing, absolute pressure. And at the end of that descent lies the outer core. And this is not what most people imagine when they think of what exists beneath their feet. We walk on concrete and soil and bedrock, and somewhere in the back of our minds, we assume the pattern continues. Solid ground all the way down, a stable foundation holding everything in place. That assumption is wrong. The outer core is liquid, not liquid like water, not liquid like anything you have ever seen or touched. It is an ocean of molten iron mixed with nickel and lighter elements, heated to 5,000 degrees Celsius. That temperature is hotter than the surface of the sun. The star that warms your face on a summer afternoon is cooler than the metal flowing beneath your feet right now. There is no surface to this ocean, no boundary where the liquid meets air. It exists in complete darkness, squeezed between the solid mantle above and the solid inner core below. A shell of churning metal wrapped around the heart of the planet, and it is anything but still. Our rivers flow through this ocean, not rivers of water, but currents of liquid iron driven by forces that operate on scales we struggle to comprehend. The heat escaping from the inner core creates convection. The rotation of the planet creates swirling patterns. The result is a turbulent, constantly shifting system of metallic flow that has been in motion since the Earth was young. These currents do not move like streams on the surface. They move slowly by human standards. They're measured in meters per year rather than kilometers per hour. But they carry unimaginable mass, billions of tons of molten metal circulating in patterns that take decades to complete their cycles. The flows generate something else. As all that conducting iron moves through the existing magnetic field, it creates new electrical currents. Those currents generate more magnetic field. The process feeds itself, an endless dynamo powered by nothing but motion and heat. Yet this is the engine that creates the magnetic shield protecting us from solar radiation. But the dynamo does something else, something that reaches all the way to the surface. The outer core is not isolated from the rest of the planet. It touches the mantle at a boundary nearly 2,000 miles down, and that boundary is where something remarkable happens. The liquid iron does not simply flow past the solid rock above it. It pushes against it. It drags on it. And it exchanges energy with it through a process called core-mantle coupling. Angular momentum is conserved. This is one of the fundamental laws of physics. Energy in a rotating system does not simply vanish. It cannot be created from nothing. It can only be transferred from one part of the system to another. When the liquid iron in the outer core changes its flow pattern, when it speeds up or slows down, that rotational energy has to go somewhere. It goes up, through the boundary, and through the mantle, through thousands of miles of slowly creeping rock, and eventually, that energy reaches the thin crust where we build our cities and measure our days. The outer core and the surface are connected by an invisible chain of momentum transfer that operates across distances almost too vast to comprehend. When the iron rivers slow down, they give up angular momentum. That momentum transfers to the mantle above. The mantle speeds up, the crust speeds up, yet the entire solid shell of the planet accelerates, even if only by fractions of a millisecond. The process works in reverse too. When the core speeds up, it can steal momentum from the mantle. The surface slows down. The days grow longer. This exchange does not happen randomly. It follows patterns that researchers have traced through decades of careful measurement. The cycles span 60 to 70 years, long enough that a human lifetime might only see one complete oscillation, and long enough that the pattern was invisible until we had instruments precise enough to detect it. The last several years fall within a phase where the core is slowing, where the liquid iron is surrendering momentum to the rock above, where the energy flows upward through the mantle and emerges at the surface as a slight, measurable quickening of the planet's spin. Picture a force operating 2,000 miles underground, in complete darkness, at temperatures that would destroy any instrument we could send to measure it. A force that has been churning since the planet formed, long before the first life appeared, long before the continents took their current shapes. That force is reaching upward right now. It travels through rock that flows like thick honey over millions of years. It crosses boundaries between different layers of material. It accumulates in the rigid lithosphere beneath our feet, and it quietly adjusts the length of every day you experience. You cannot feel it. No human sense is calibrated to detect the difference between a day that is 1 millisecond shorter and a day that is not. But the atomic clocks feel it. The satellites in orbit feel it. The quasars billions of light years away, their signals arriving at radio telescopes around the world, are used to measure it. The planet beneath you is not solid and static, yet it is a machine of interlocking fluids and solids, each one pushing and pulling against the others. The outer core is just the first gear in that machine, the first place where the energy that speeds our days originates. But it is not the only place. The descent continues, deeper still, past the churning iron ocean, past the zone where liquid meets solid, past temperatures that remain constant despite the crushing pressure. 4,000 miles from the surface, here's something else waits in the darkness, something that has only recently revealed a secret that changes everything we thought we understood about the stability of our world. Past the churning liquid metal, past the zone where iron flows like water in slow motion, past everything that moves and swirls and transfers its energy upward through thousands of miles of rock. Here, at the very center, something waits, a solid sphere, not liquid, not flowing, solid iron, compressed beyond anything that exists on the surface. The pressure at this depth defies imagination. 3.5 million times the atmospheric pressure at sea level. Squeeze iron hard enough, long enough, and even at temperatures that would vaporize steel in an instant, the metal cannot escape into liquid form. The atoms are locked in place, crushed into stillness. This is the inner core, roughly the size of the moon, 750 miles across. A solid iron ball suspended in a sea of molten metal, spinning in eternal darkness at the exact center of the planet. Picture it, a planet within a planet. A hidden moon buried beneath 2,000 miles of liquid iron and another 2,000 miles of slowly churning rock. No light has ever reached it. No probe will ever touch it. It exists in complete isolation, separated from the surface by distances and pressures that make direct observation impossible. And it may be spinning in the wrong direction. For decades, seismologists believed the inner core rotated slightly faster than the rest of the planet. They called it superrotation. When earthquakes sent tremors rippling through the Earth, the waves that passed through the center arrived at distant monitoring stations a fraction of a second earlier than expected. The interpretation was straightforward. The inner core was outpacing the surface, racing ahead by a tiny amount each year, and completing its own private orbit inside the larger orbit of everything above it. The evidence seemed solid. Multiple studies, multiple research teams, the same conclusion. Then, in 2023, a paper appeared in Nature Geoscience that complicated everything. Researchers examined seismic data spanning 50 years of earthquakes. They tracked how waves passing through the inner core changed over time. The pattern they found was not what anyone anticipated, and the superrotation appeared to have stopped. Some interpretations of the data suggested something even stranger. The inner core might be spinning slower than the surface now. It might even be moving backward. A solid iron sphere the size of the moon, buried at the center of the Earth, potentially rotating in the opposite direction of the ground you stand on. Everything above it turns one way: the crust, the oceans, the atmosphere, and the cities where you sleep, and the roads you drive, and the satellites that orbit overhead, all of it spinning east. And at the very center, separated by 4,000 miles of rock and metal, a hidden world that might be drifting west. We don't really know if the inner core is reversing or just slowing. That's the honest answer. Multiple research teams have looked at the same seismic data and reached different conclusions. What we do know is that something changed. And when something changes 4,000 miles underground, the effects ripple upward. Reading seismic waves is not like reading a thermometer or watching a clock. It is more like trying to determine the shape of a room by listening to echoes. You can infer walls and corners. You can estimate distances and angles, but you cannot see them. The waves travel through materials of different densities and compositions. They bend, they scatter. They arrive at surface stations carrying information that must be decoded, interpreted, argued over. Some scientists believe the inner core oscillates. It speeds up for decades, then slows down, then speeds up again. A pendulum buried at the center of the world, swinging back and forth on timescales that span a human lifetime. Others believe the recent changes represent something new, a shift in the fundamental dynamics of the deepest layer of the planet. The debate continues. But something that is not debated is this. The inner core is not a passive object. It is not simply sitting at the center while everything else moves around it. It exchanges energy with the layers above. When the inner core changes speed, it tugs on the liquid iron surrounding it. That liquid iron tugs on the rocky mantle. The mantle tugs on the crust. The signal propagates upward through 4,000 miles of material, losing clarity at every boundary, arriving at the surface as a whisper that only the most precise instruments can detect. Consider the strangeness of this arrangement. The solid inner core, suspended in liquid metal, the liquid outer core, pressed against the solid mantle above, each layer moving at slightly different rates, each one pushing and pulling against its neighbors. The whole system connected by invisible forces that operate across distances almost too vast to comprehend. Yet what happens at the center does not stay at the center. If the inner core is slowing, it is releasing angular momentum. That momentum has to go somewhere. It flows into the liquid iron above. The outer core absorbs it. The outer core then transfers some of that momentum to the mantle. The mantle transfers it to the crust. The process takes time, years, decades. The signal is filtered and delayed by thousands of miles of intervening material, but it arrives, and a machine in a basement laboratory in Boulder, Colorado, records the result. The atomic clock does not care about scientific debates. It does not weigh competing interpretations of seismic data. It does not publish papers or attend conferences or argue over methodology. It simply counts. 9 billion oscillations of cesium atoms, marking each second with absolute precision. And if those seconds stack up to reveal that the planet is spinning faster than expected, yet the clock records that fact without comment, the inner core may be reversing, or oscillating, or doing something that no current theory fully explains. The clock measures what reaches the surface. It tracks the combined effect of every force acting on the planet: core dynamics, mantle convection, ocean currents, atmospheric pressure, all of it merged into a single number, the length of the day. That number has been getting smaller, as something deep inside the Earth is contributing to that acceleration. The outer core, with its rivers of liquid metal, plays a role. The inner core, with its mysterious changes in rotation, plays another. The signals mix together as they travel upward. By the time they reach the surface, separating one influence from another becomes extraordinarily difficult. But the journey of those signals is not finished. Between the inner core and the surface lies the thickest layer of all, the mantle. 2,000 miles of rock that flows like cold syrup over millions of years. Rock that carries heat from the deep interior toward the crust. Rock that rises and falls in vast convection cells spanning continents. Rock that holds the memory of ancient impacts and forgotten ocean floors. The signal must pass through all of it to reach you. The rock beneath your feet is not still. It moves, not in ways you can feel, not in ways you would ever notice in a single lifetime. But it moves. The mantle, that vast layer between the molten core and the thin shell of crust where you live, is in constant motion. It has been moving since before there were continents. It will be moving long after the last mountain has worn to dust. Picture the distance from New York to Los Angeles. Now multiply that by 3. That is how thick the mantle is. 1,800 miles of rock, separating the liquid iron below from the air you breathe. If you could somehow walk through it, traveling 20 miles a day, it would take you 247 years to reach the other side, and every inch of that distance is solid rock. This seems like a contradiction. How can something solid be moving? How can rock flow? The answer lies in time. On the scale of a human life, the mantle is as rigid as anything you have ever touched. Strike it with a hammer, and it rings like a bell. Build a house on it, and that house will stand for centuries without the ground beneath it shifting in any direction you could measure. But on the scale of millions of years, something different happens. Rock behaves like a fluid when you give it enough time. Not water, not even oil. Something far stranger. Imagine taking a jar of honey and placing it in a freezer. Not long enough to turn it solid, but long enough to make it thick, almost impossibly thick. Now tip the jar on its side and wait. At first, yet nothing happens. The honey seems frozen in place. An hour passes. Still nothing. A day, a week. You begin to wonder if it will ever move at all. But if you could watch that jar for 1,000 years, you would see the honey slowly, impossibly slowly, begin to creep toward the lower edge. It would pour in the way glaciers pour down mountainsides. Too slow to see, too fast to ignore over geological time. That is the mantle. Heat rises from the core. Temperatures down there reach thousands of degrees. That heat does not stay trapped. It pushes upward, warming the rock directly above. And warm rock, even rock that seems completely solid, is slightly less dense than the cooler rock around it. So it rises, not like a bubble rising through water, more like a thought rising through a dream, gradual beyond any human frame of reference. These currents have a name: convection cells. They operate on scales that dwarf anything on the surface. A single convection cell can span the width of an ocean. The rock within it rises toward the surface over the course of 50 million years, spreads outward beneath the crust, cools, and then sinks again. The complete cycle takes longer than some species exist on this planet. This is the engine that moves continents. The Atlantic Ocean grows wider by about an inch each year because molten rock is welling up from the mantle along a ridge that runs down its center. And the Pacific shrinks by roughly the same amount because its edges are diving back down into the deep. Entire ocean floors are created, age, and disappear on timescales that make human civilization look like a blink. But the mantle is not uniform. Deep down, near the boundary where solid rock meets liquid iron, something unexpected sits. Two massive structures, each larger than a continent. Scientists call them large low-shear velocity provinces. The name comes from how seismic waves behave when they pass through these regions. The waves slow down. They lose speed in ways that suggest the material inside is different from the mantle surrounding it. One of these structures lies beneath Africa, the other beneath the Pacific Ocean. Together, they cover a significant portion of the core mantle boundary. Each rises hundreds of miles into the mantle above. If you could somehow remove all the rock between them and the surface, and they would tower over any mountain range ever lifted by plate tectonics. We do not know what they are made of. This is the part that should make you pause. We have sent robots to Mars. We have photographed the icy moons of Jupiter. We have mapped the terrain of distant asteroids with precision measured in feet. But these structures, buried inside our own planet, remain fundamentally mysterious. Their composition is unknown. Their origin is debated, and their role in the grand mechanics of planetary convection is still being argued in academic journals. We have mapped the surface of Mars in greater detail than we have mapped these hidden continents inside Earth. Some researchers believe the structures are ancient, perhaps remnants of the primordial material from which the planet formed, somehow preserved for over 4 billion years in the crushing depths. Others suggest they might be the accumulated debris of subducted ocean floors, a rock that dove into the mantle hundreds of millions of years ago and piled up at the bottom, like sediment in a slow drain. Still others propose entirely different explanations. The honest answer is that we do not know. What we do know is that they interact with everything around them, the core below them, the convection currents that flow past them, the plumes of hot material that may rise from their edges toward the surface. Yet these structures are not passive observers of planetary dynamics. They shape the flow of the mantle in ways we are only beginning to understand. They may influence where volcanoes form. They may help determine which continents drift toward each other and which drift apart. And they almost certainly play a role in how forces from the core reach the surface. Remember the signal traveling upward, the changes in the outer core, the mysterious shifts in the inner core, the exchange of angular momentum between layers. None of that reaches you directly. It passes through the mantle first, through 1,800 miles of slow-moving rock, through convection cells that take tens of millions of years to complete a single cycle, past those continent-sized anomalies whose very nature we cannot explain. The mantle acts as a filter, a transmission layer, a medium through which deep forces propagate on timescales that mock human impatience. Yet what begins as a change in core rotation becomes, decades later, a fraction of a millisecond difference in the length of your day. The chain of causation stretches across thousands of miles of rock, handed off from layer to layer, dampened and delayed at every boundary. The signal arrives, the atomic clock records it. But the journey took longer than a human career. Everything discussed about the core, every shift and oscillation and mysterious reversal, reaches the surface through this vast, slow river of rock. The mantle carries it upward the way a glacier carries boulders. Not quickly, not cleanly, but inevitably. What happens at the bottom eventually expresses itself at the top. Yet the forces shaping Earth's rotation do not come only from below. The forces are real. The shifts in the core, the slow churning of the mantle, the signals propagating upward through thousands of miles of rock. All of it is happening. But how do we know? How can anyone claim to measure something as vast as a planet's rotation down to a fraction of a millisecond? The answer requires us to step back from the machinery inside Earth, to look instead at the machinery we built to watch it. For most of human history, measuring Earth's rotation meant one thing: watching the sky. Ancient astronomers tracked the apparent movement of stars across the heavens. They built stone circles and bronze instruments. They recorded the moment a particular star crossed a particular line. Night after night, year after year, the rotation of Earth was written in the wheeling of constellations. This worked. For thousands of years, it was the only method available, but it had limits. Stars are not truly fixed. They drift relative to each other, slowly, over centuries. The very reference points astronomers depended on were themselves in motion. Measuring Earth against a moving background meant the measurements carried uncertainty. The picture was blurry at the edges. Then came a revolution in the measurement of time itself. In the 1950s and 60s, physicists discovered they could count something far more reliable than stars: atoms. Specifically, the vibrations of cesium atoms, which pulse at an extraordinarily consistent rate. These vibrations became the heartbeat of a new kind of clock, one that did not depend on anything in the sky, one that counted time by the unchanging behavior of matter itself. Suddenly, humanity could measure duration with a precision that would have seemed like sorcery to any previous generation. A single second could be divided into billions of identical slices. Drift that once took years to accumulate could now be detected in hours. So the clock had become sharper than anything it was meant to measure. But here is something important. Measuring time with extreme precision is not the same as measuring rotation with extreme precision. A clock tells you how long something took. It does not tell you where you are pointing in space. To know that, you need a different kind of tool. You need a fixed reference point somewhere outside the Earth, something that does not move. The stars were not fixed enough. As the sun shifts against the background of distant galaxies, even the planets wobble in their orbits. Scientists needed something more stable, something so far away that any motion it possessed would be invisible from Earth. They found it in the most unexpected place, at the very edge of the observable universe: quasars. The name comes from quasi-stellar radio source, a term coined when astronomers first detected them and could not explain what they were seeing. And we now know that quasars are the blazing cores of ancient galaxies, powered by supermassive black holes consuming matter at tremendous rates. They emit light and radio waves with furious intensity. Some shine brighter than 1 trillion suns. But the property that matters for measuring Earth is not their brightness. It is their distance. Quasars are billions of light years away, so far that the light reaching us now began its journey when our planet did not exist. When our solar system was nothing but a dispersed cloud of gas and dust, those photons were already traveling. They crossed the void for eons before Earth had even formed. At such distances, something remarkable happens. A quasar appears utterly motionless. It might be hurtling through space at thousands of miles per second, but from our perspective, that motion is invisible. The object is simply too far away for any movement to register. Imagine standing at the edge of a vast canyon and watching a person walk on the opposite rim. At a few hundred feet, you see them moving clearly. At 10 miles, they seem to crawl. At 1,000 miles, if you could somehow still see them, they would appear frozen in place. Scale that up by a factor of billions, and you have quasars. They are the fixed thumbtacks on the map of the universe, the most stable reference frame humanity has ever found. Against them, we measure our own wobble. The technique that uses quasars to track Earth's rotation is called Very Long Baseline Interferometry. The name is technical, but the concept is surprisingly intuitive. Radio telescopes are placed on opposite sides of the planet. One might be in Hawaii, another in Germany, a third in Australia. These telescopes all point at the same quasar, listening to the radio waves it emits. Because the telescopes are separated by thousands of miles, yet the radio signal from the quasar arrives at each one at a slightly different time. The difference is tiny, a few billionths of a second, but it can be measured, and from that difference, scientists can calculate exactly how the Earth is oriented in space. It is like having two ears on opposite sides of the planet, listening to the same whisper from the edge of the observable universe and comparing notes. The whisper arrives at one ear a fraction of a moment before the other. At that fraction, tells you which way you are turned. The precision is extraordinary. Using this method, researchers can determine Earth's orientation to within a few millimeters. They can detect changes in the length of a day that amount to millionths of a second. They can see the planet nod and wobble and shift in ways that no human sense could ever perceive. And here is the part that borders on absurdity. The most precise measurements of our planet's rotation depend on light that left distant galaxies when Earth did not even exist yet. We are using ancient photons, born in the violent hearts of galaxies billions of years ago, to track the spinning of a world that would not form for eons after those photons began their journey. The scale of it resists comprehension. Light traveling for billions of years across nearly empty space, finally arriving at a dish-shaped antenna in a field somewhere, as where it is converted into data, compared against light that arrived at another antenna thousands of miles away and used to calculate that today was 1.6 milliseconds shorter than expected. This is how we know what we know, not through intuition, not through watching sunrises, through a network of telescopes spread across continents, all listening to the faint radio hum of objects so distant they make our entire solar system look like a mote of dust. The technology revealed something we could never have discovered otherwise. It showed us that Earth's rotation is not steady. It fluctuates. It responds to forces acting from within and without. The core shifts and the surface registers it. Ice melts and the spin adjusts. Weather patterns flow and the planet notices. Before very long baseline interferometry, these changes were invisible. We had no reference stable enough to reveal them. The stars moved too much. Our clocks were not precise enough. The wobble of the world was hidden inside the noise of our instruments. But once we found those distant, frozen points of light, everything changed. The noise fell away, the signal emerged. And what the signal showed us was a planet in constant motion, adjusting and readjusting, responding to pressures from below and above. The quasars do not care about Earth, as they blazed for billions of years before our world existed and will continue long after it is gone. But their light, arriving here after crossing nearly the entire visible universe, gives us something precious, a still point, a reference, a way to measure ourselves against the cosmos. And when scientists pointed these tools at our own planet, they discovered something unexpected happening at the surface, something involving ice, something that should have been slowing the Earth down, but seemed to be doing something else entirely. The forces shaping Earth's rotation do not come only from below. They also come from above, from the surface, from the weight of ice stacked miles high at the top and bottom of the world. We have spent time in the core, in the mantle, in the crushing darkness where iron flows like water and pressure turns solid rock into something that remembers. But now we need to look up, to the places we can actually see, to the ice. Greenland holds 2.6 million cubic kilometers of frozen water. That is not an easy number to picture. Try this. If all of that ice melted, it would raise global sea levels by 7 meters. That is 23 feet. Every coastal city on Earth would begin to drown. New York, Shanghai, Mumbai, Amsterdam, all of them would start to disappear under the rising tide. That is how much ice sits on a single island in the North Atlantic. Antarctica holds even more, enough ice to raise sea levels by 60 meters, 170 feet. If Antarctica melted completely, the coastlines of every continent would be redrawn. Maps would become historical documents. And all of that potential energy, all of that frozen future, sits at the poles right now, pressing down on the rock beneath it. These ice sheets are not stable. They are bleeding. Greenland is losing 270 billion tons of ice every year. That number needs context. In the 1990s, Greenland was losing about 30 billion tons per year. 30 billion tons sounds like a lot, and it is. But compare it to today, 270 billion. That is a 9-fold increase in roughly 3 decades. Not a gradual acceleration, not a slow creep upward, a 9-fold increase. The rate of loss has multiplied by 9 in the span of a single human generation. Antarctica is losing 150 billion tons per year. Combined, the 2 polar regions are dumping over 400 billion tons of ice into the oceans every single year. 400 billion tons. Imagine a cube of ice 1 kilometer on each side. Solid, heavy, massive. Now imagine 400 of those cubes vanishing into the sea every 12 months. That is what is happening right now. Think of ice sheets as frozen batteries storing angular momentum at the poles. When they discharge into the oceans, that stored energy does not vanish. It redistributes as it flows outward toward the equator. Here is where the physics becomes elegant and troubling. Angular momentum is conserved. We touched on this earlier, deep in the core, where spinning iron trades momentum with the mantle. The same law applies here, at the surface, in the ice. When mass moves from the poles toward the equator, the planet's moment of inertia changes. The distribution of weight shifts. And according to the physics, when you push mass outward from the center of rotation, the spin must slow to compensate. Picture a spinning top with small weights attached near the center. Now imagine sliding those weights outward toward the rim. The top does not keep spinning at the same rate. It slows down, not because something is pushing against it, not because friction is fighting it, simply because the distribution of mass has changed. The system must balance itself. Melting glaciers redistribute mass like sliding weights on a spinning top, or push the weights outward toward the rim, and the top must slow to conserve its angular momentum. That is not a metaphor. That is the physics. The math is clean. The principle is absolute. When ice at the poles melts and the water flows toward the equator, Earth should decelerate. 400 billion tons of water moving equatorward every year. That is not a small perturbation. That is a planetary-scale force acting on the rotation of our world, and it is accelerating. Yet the 9-fold increase in Greenland's ice loss means this force is growing stronger with each passing decade. The water does not stay where the ice was. It spreads. It enters currents. It distributes itself across the global ocean, settling toward lower latitudes where the bulge of the equator pulls it outward. The spinning Earth redistributes this mass automatically, spreading the weight along its widest circumference. This is the part that gets me. The physics is simple. A mass moves from the poles to the equator. The planet should slow, and yet it's speeding up. The equations work. The data is clear. Something else is overpowering a force moving 400 billion tons of water a year. The ice is doing exactly what the physics predicts. It is melting. It is flowing. It is redistributing mass toward the equator. It is pushing against the planet's rotation, trying to slow it down, applying a brake that should register in every atomic clock on Earth. But the clocks tell a different story. The days are getting shorter. The rotation is accelerating. June 29, 2022 happened despite 400 billion tons of ice fighting to make it last longer. This is the paradox. The surface is pushing one way, the depths are pushing another, and right now, the depths are winning. The ice sheets are massive. The physics is undeniable. The angular momentum must be conserved. And yet, the planet spins faster with each passing year, as if the ice does not matter, as if 400 billion tons of water redistributing across the globe is just noise in a larger signal. It is not noise. It is a genuine force, a measurable force, a force that should be slowing us down by microseconds every year. Something beneath the surface is overpowering it, something we cannot see from space, something that reaches up from the deep interior and pushes harder than all the melting ice on Earth. The batteries at the poles are discharging. The stored angular momentum is flowing toward the equator. The physics says the planet should be decelerating, but the planet is not listening to the ice. It is listening to something else, something deeper, something stronger, and that something has not finished speaking. Two forces are pulling in opposite directions right now. One is buried so deep no human will ever see it. The other is melting in plain view, collapsing into oceans, flooding coastlines that have been stable for thousands of years. Neither force knows the other exists. The molten currents churning beneath the mantle operate in total darkness. They have been transferring momentum to the surface for longer than life has existed on this planet. They do not respond to temperature changes in the atmosphere. They do not care about the composition of the air. They follow rules written in pressure and heat and the slow circulation of liquid metal, and they are currently winning. The ice at the poles is doing everything physics demands. It is melting. It is flowing. It is redistributing its ancient weight toward the equator. Every ton that leaves Greenland, every glacier that carves into the Southern Ocean, every meltwater stream cutting channels through ice that has been frozen for tens of thousands of years, all of it is pulling against the planet's rotation. All of it is trying to slow us down. But right now, in this moment, the deep Earth is pushing harder. Picture a rope stretched tight between two teams. On one end, invisible forces from the planet's interior. On the other end, the visible flood of water pouring from the poles. The rope is the spin of the planet itself. Every rotation, every day, every sunrise and sunset that marks your passage through time, that rope is being pulled from both directions simultaneously. The team you cannot see is stronger. The team you can see is growing. A machine sits in a basement laboratory in Boulder, Colorado. It counts the vibrations of atoms with a precision that borders on the absurd. It does not understand context. It does not know why the planet speeds up or slows down. It simply records who is winning the tug of war, a moment by moment, with perfect neutrality. And for the past several years, that machine has been recording the same result. The deep forces are ahead. The core is pulling the rope faster than the ice can pull it back, but the ice is not finished. Every year, the melt accelerates. Every year, more weight shifts from the frozen poles toward the bulging equator. Every year, the team on the surface gains members, gains strength, gains leverage. So the core operates on cycles that stretch across human lifetimes. Its influence rises and falls over decades. The forces driving the current acceleration will eventually weaken, as they have weakened before, as they will weaken again. This is not speculation. This is the pattern written in the seismic record. The ice operates on a different schedule now, a schedule written by atmospheric carbon and ocean temperatures and the accumulated heat of industrial civilization. Unlike the core, the ice is not cycling, it is accelerating. The amount of water leaving the poles this decade will be exceeded by the amount leaving next decade, and the decade after that, and the decade after that. At some point, the balance tips. Nobody knows exactly when. The mathematics are too complex. Too many variables interact in ways we cannot fully model, but the trajectory is clear. The deep forces will weaken. The surface forces will strengthen, and when those two curves cross, the rope will begin moving in the other direction. The acceleration will stop, the days will stop getting shorter, and the ancient pattern of deceleration will resume. But here is the part that matters. When that happens, it will not be the gentle, predictable slowing that governed this planet for billions of years. It will be amplified, accelerated, driven not just by the moon's patient gravitational drag, but by the weight of water that humanity's warming has released from polar storage. So the future holds longer days, not shorter ones. Not because the universe has changed its rules, because we have added a new force to the equation. Consider what this means. For most of Earth's history, the slowing was gradual, imperceptible across human timescales. The moon pulled, the tides dragged, the rotation decelerated at a rate measured in milliseconds per century. Life adapted. Civilizations rose and fell, and nobody noticed the days growing longer, because the change was so small, it vanished into the noise of existence. That is no longer the trajectory we are on. The ice sheets represent something that took hundreds of thousands of years to accumulate. weight that was locked in place through ice ages and interglacials, through the rise of mammals and the extinction of species, through the emergence of humans and the construction of everything we have ever built. And that weight is now entering the system, not slowly, not gradually, at a pace the planet has rarely experienced outside of catastrophic events. When the balance shifts and the ice begins winning the tug of war, the deceleration will carry the fingerprint of this moment. The future will slow faster than the past because we have added so much water to the equation. Days will lengthen, not at the ancient rate, but at a rate shaped by the choices we made. And a machine in a basement laboratory in Boulder, Colorado, will record this transition. It will note the moment the days stop getting shorter. It will measure, with atomic precision, the beginning of a new phase in the planet's rotational history. It will not judge. It will not assign blame. It will simply count the oscillations and report the result. The rope is still being pulled. The core is still ahead, but the lead is temporary. Somewhere beneath Greenland, meltwater is carving channels through ice that has been frozen since before humans discovered fire. Somewhere in Antarctica, glaciers that have held their ground for millennia are accelerating toward the sea. Somewhere in the mountain ranges of the world, snowpack that has been reliable for generations is failing to return each winter. All of it is adding weight to one side of the tug of war. The deep earth does not know what is happening on the surface. Now, the surface does not know what is happening in the deep earth. Both are pulling. Both are relentless. Both operate on timescales that dwarf human concerns. And between them, caught in the tension of the rope, the atomic clocks keep counting, recording this moment, recording this competition, recording the strange, brief era when forces from the interior temporarily overpowered forces from the surface. It will not last. The ice is catching up. Yea, but the ice is not finished complicating the picture. There is a second effect at work, a hidden force most people have never considered, one that reaches back through time itself. It is called post-glacial rebound, and it changes everything. During the last ice age, ice sheets sat on this planet that would dwarf anything we see today. 3 kilometers thick, that is nearly 2 miles of frozen water pressing down on the continents. North America vanished beneath it. Europe disappeared. Yet the weight was beyond comprehension, and the rock beneath responded. Bedrock is strong. It can hold mountains. It can resist earthquakes. But even rock has limits. When 2 miles of ice presses down for thousands of years, the rock bends. Slowly, imperceptibly, but undeniably. The crust of the planet sagged under the load. The mantle below, that thick layer of hot flowing stone, was pushed aside to make room. Then, 11,000 years ago, the ice melted. The weight lifted. Yes, the glaciers retreated. The frozen covering that had defined the landscape for 100,000 years simply vanished. And you might expect the rock to spring back immediately, like a trampoline after you step off, like a diving board after you jump. It did not. The earth moves slowly. The mantle that was displaced had to flow back. The crust that was bent had to unbend. And this process takes time, unimaginable time. Time measured not in years or centuries, but in millennia. Yet consider this. The ice has been gone for 11,000 years. Human civilization emerged, flourished, built cities, invented writing, created empires, developed technology. All of recorded history fits within this window. Every pyramid, every cathedral, every rocket launch. And the rock is still rising. Scandinavia lifts at 1 centimeter per year. That might sound trivial. A centimeter is the width of your fingernail. But it has been doing this for 11,000 years. And it will continue for thousands more. The total rise in some regions has already exceeded 300 meters. That is taller than the Eiffel Tower. And the ground is not finished. The earth remembers. It remembers ice that has not existed since before the first farmer planted the first seed. It remembers weight that vanished before the invention of the wheel. The bedrock carries this memory in its slow, patient rise, like a foam pillow regaining its shape after you lift your head. Except the pillow is continental bedrock. The weight was a glacier 2 miles thick, and the recovery takes millennia. This is what happens when you bend a planet. The rise matters. The physics matters. Because as the land lifts, it pulls mass with it. Rock that was compressed is now expanding. Material that was pushed toward the equator during the Ice Age is slowly migrating back toward the poles. This creates a counterforce. Ancient melting pulling mass in one direction, and modern melting pushing it in the other. Two ice ages, separated by 11,000 years, locked in their own slow battle. The ice that exists today is melting. That water flows toward the equator. It spreads across the ocean basins. It should slow the planet down. We have established this, but the ice that vanished 11,000 years ago is still exerting its influence. The rebound it triggered is still in progress. The mass migration it started is still underway, and this ancient process is pulling weight back toward the poles, working against the modern melt, counteracting some of its effects. The planet is caught between memories. One memory is fresh, the glaciers that are dying now, the ice sheets that are thinning as we speak. Their water is entering the system in real time, measurable, visible, documented by satellites and scientists. The other memory is ancient, written in rising coastlines and tilting landscapes, in harbors that were once at sea level but now sit hundreds of meters inland, in geological evidence that requires careful measurement to detect. Both memories are active, both are shaping the rotation, both are pulling the rope in this cosmic tug of war, and beneath the ice that remains, hidden complexity waits. Antarctica holds secrets we are only beginning to understand. Over 400 lakes exist beneath that frozen continent. Not frozen lakes, liquid water, and held above freezing by geothermal heat from below and insulated by kilometers of ice above. Some of these lakes are the size of small seas. Ecosystems might exist there, life forms isolated for millions of years. These lakes interact with the ice above them. They lubricate, they destabilize, they create conditions we cannot fully predict. In 2022, something happened that captured this unpredictability perfectly. The Conga ice shelf collapsed. Yet this was not a gradual process, not a slow deterioration measured over decades. The Conga shelf was the size of Rome. It had existed for thousands of years. Satellite images from before and after show the transformation. In less than a week, it was gone. Structure that had persisted since before the Roman Empire. Ice that had maintained its position through the rise and fall of civilizations. Frozen architecture that predated every nation currently on Earth. Shattered, dissolved, yet released into the ocean. 1 week. This is the nature of ice. It can hold for millennia. It can seem permanent. It can give no indication that anything is wrong. And then, when conditions align, when the invisible stresses accumulate beyond a threshold we cannot see, it fails, catastrophically, completely. The Conga Shelf was not the largest. It was not the most important for sea level rise, but it was a signal, a message written in fractured ice and sudden absence. The system is not stable. The ancient rebound continues. The modern melt accelerates. 400 lakes wait beneath Antarctica. Ice shelves that have stood for thousands of years can vanish in days. And threading through all of this, the rotation of the planet changes, milliseconds accumulating, the tug of war continuing, forces from 11,000 years ago colliding with forces from this afternoon, and the atomic clocks in their basement laboratories cannot know what the ice is doing. They simply record the result, the accumulated consequence of a planet caught between its past and its present. Geological memory operates on timescales that dwarf human experience. We measure our lives in decades. We measure history in centuries. The Earth measures in millennia. And in that longer accounting, 11,000 years is recent. The Ice Age just ended. The recovery is still underway. Yet we are living in the geological aftermath, building our cities on land that is still rising, watching ice collapse that has stood since before civilization began. The bedrock remembers weight that no living thing has ever seen. The bedrock remembers. But the bedrock is not the only thing pressing against the planet's motion. There is something else, something you cannot see, something you walk through every moment of your life without ever feeling its weight. Air. Now, the atmosphere does not feel heavy. You breathe it without effort. You move through it without resistance. It seems like nothing at all. But the atmosphere is not nothing. It extends 100 kilometers above the surface. 100 kilometers of gas, layered and compressed, pressing down on everything beneath it. Every square inch of your body, every square inch of the ground, every square inch of ocean receives the same constant pressure, 14.7 pounds, per square inch, all the time, the weight of a bowling ball, balanced on an area the size of a postage stamp, everywhere at once. You do not feel it because you have never known anything else. The pressure inside your body matches the pressure outside. Your bones, your lungs, your blood vessels, all built to operate under this invisible load. You are adapted to being crushed, gently, continuously, from the moment of your first breath. They stack every building ever constructed by every civilization in human history, every pyramid, every cathedral, every skyscraper, every mud hut and stone wall and concrete tower. Pile them all together into one unimaginable mass. The atmosphere is heavier. 11 quadrillion pounds of gas suspended above the surface, held in place by gravity alone. This mass moves, not randomly, not chaotically. The atmosphere moves in enormous organized patterns, rivers of air that circle the planet, currents that flow faster than sound in some places, slower than walking in others, jet streams sitting 6 to 9 miles above the surface, invisible highways that commercial aircraft ride to save fuel. These rivers of wind exceed the speed of the planes that travel through them, faster than any vehicle humanity has built, faster than bullets from some weapons. And this is just air. The jet stream is a river of air moving faster than a commercial airliner, invisible, weightless seeming, yet massive enough that when it meanders, when it shifts north or south by even a small amount, the transfer of momentum can measurably change the length of a day. Angular momentum is conserved. This principle appeared first in the core. It appeared again in the ice. Now it appears in the air. When the atmosphere speeds up in one direction, something else must slow down. When wind patterns shift, when jet streams wander, the solid earth beneath receives the difference. Yes, the planet and its atmosphere are locked together, spinning as one system. What happens in the air does not stay in the air. The atmosphere breathes, not like you breathe, not in and out through lungs. The atmosphere breathes with the seasons. In summer, the air over land heats up, it expands, it rises. The atmospheric mass redistributes itself, spreading outward from the warming continents. In winter, the opposite happens. The air cools, it contracts, it settles closer to the surface, it closer to the axis of rotation. Every breath nudges the planet, like a hand on a spinning top, gentle but persistent. Summer slows it down, ever so slightly. Winter speeds it back up, a rhythm as old as the tilt of the Earth's axis, as predictable as the orbit around the Sun. But something is changing. Global temperatures have risen 1.2 degrees Celsius above pre-industrial levels. This number sounds small. It is not small. And it represents an enormous amount of additional energy trapped in the system. Energy that does not sit still. Energy that drives winds, moves water, reshapes the patterns that have governed atmospheric circulation for longer than civilization has existed. The Arctic is warming 4 times faster than the global average. 4 times. The coldest region on Earth is heating more rapidly than anywhere else. This is not a uniform warming. It is a distortion. A warping of the temperature gradients that drive atmospheric movement. Jet streams exist because of temperature differences. Cold air over the poles, warm air over the tropics, and a boundary between them where the rotation of the Earth creates these high-altitude rivers of wind. When that temperature difference weakens, the jet stream changes. It slows. It wobbles. It meanders in larger, lazier loops that can stall weather patterns for weeks at a time. And these changes alter how angular momentum transfers between the atmosphere and the surface. The seasonal breathing becomes irregular. The predictable rhythms of expansion and contraction become harder to model, harder to anticipate. The invisible hand on the spinning top is no longer pressing where it used to press. Scientists measuring Earth's rotation have noticed increased variability in recent decades. Day lengths fluctuate more than they did before, while the milliseconds come and go less predictably. Some of this variability comes from the core, some comes from the ice, and some comes from above, from the air that seems to weigh nothing but weighs 11 quadrillion pounds, from wind patterns that seem unconnected to solid ground but are fundamentally, physically, rotationally coupled to every rock and ocean and glacier beneath them. The atmosphere carries signals we are only beginning to read. And when a major volcanic eruption injects ash into the stratosphere, the change in atmospheric loading affects rotation. When an El Niño event shifts warm water across the Pacific and rearranges wind patterns over half the planet, the rotation responds. When a persistent high-pressure system parks itself over a continent for months, the angular momentum transfer accumulates. Climate change is not just about temperatures, it is about motion, the motion of air masses, the motion of ocean currents, the motion of heat through systems that have operated in relative balance for millennia. And through all of it, the rotation of the planet keeps score. Every shift in the wind becomes a shift in the day. 14.7 pounds per square inch, 11 quadrillion pounds total, rivers of air moving faster than aircraft, seasonal breathing that nudges the spin of a planet, temperature changes that alter patterns older than human memory. Air is not nothing. Yes, sir, but the atmosphere is only one of the forces acting from above. There is another one, and this one was not caused by nature. Everything you have heard so far has been the work of nature, the core churning in darkness, the ice remembering ancient weight, the atmosphere pressing down with its invisible tonnage, forces that have shaped this planet since before there was anyone to witness them. But there is something else now, something new, human beings. Yet we have become a force that moves the earth, not through intention, not through any grand design, through the simple, accumulated actions of billions of people trying to grow food, trying to drink water, trying to live. Consider groundwater, water that exists beneath the surface, trapped in ancient aquifers, locked in stone for thousands of years. This water does not flow, it does not move on its own. It simply waits, deep underground, while the world above changes and changes again. And then someone drills a well, then someone else, then millions of people across continents pumping water upward to irrigate fields, to fill reservoirs, to sustain cities that could not exist without it. The water rises, it leaves the aquifer, it enters the cycle of surface life, flowing through crops, through rivers, through pipes, eventually reaching the sea, and the aquifer grows lighter. This has been happening at massive scale for decades. Between 1993 and 2010, humanity extracted enough groundwater from beneath the continents to reshape the geometry of the planet. Not by a little, not by an amount that requires sensitive instruments to detect, by 80 centimeters, about 2.5 feet. The physical pole of Earth's rotation, the axis around which everything turns, drifted to the east by that much because of how we farm. Picture a ship spinning slowly in water, a massive cargo vessel rotating on its axis. Deep in the hold, workers begin moving crates from the port side to the starboard side. Each crate is small compared to the ship. Each individual worker moves an insignificant amount of weight, but multiply those workers by thousands. Give them decades to work. Watch as the accumulated shifting of cargo causes the entire vessel to list, the axis of its spin tilting measurably to one side. That is what we have done. Each farmer pumping water, each irrigation system drawing from deep wells, each city drinking from aquifers that took millennia to fill. The weight shifted from beneath continents toward the oceans. The planet tilted. A study published in 2023 traced this connection with precision. Researchers looked at the redistribution of water mass across the planet. They compared it to the observed drift in Earth's rotational pole. The numbers matched. Human water use accounted for the shift, not volcanoes, not earthquakes, and not the slow grinding of tectonic plates. People, growing food, Let that sit for a moment. The crops that feed the world have measurably altered the orientation of the planet. The rice paddies of Asia, the wheat fields of North America, the irrigated farmland that sustains billions of lives. All of it, collectively, over decades, has changed which direction Earth points as it spins through space. This is not a metaphor. This is not poetry dressed up as science. This is measurement. Observation, data. The effect works in both directions. We have not only removed mass from the continents, we have also trapped it. Consider the largest engineering project ever undertaken, a wall of concrete stretching across a river valley in central China, the Three Gorges Dam. This structure holds back an artificial lake, 39.3 billion cubic meters of water, enough to cover a small country several feet deep, water that would otherwise have flowed to the Pacific Ocean, it joining the mass at the equator, contributing to the redistribution that comes from all flowing rivers. Instead, that water sits, locked behind concrete, held hostage from the sea, a mass anchor preventing that particular weight from reaching its natural destination. The dam creates a counteracting force. While groundwater pumping shifts mass toward the oceans, the dam holds mass back. While aquifers empty and tilt the axis one direction, the reservoir fills and nudges it another way. A human engineering on both sides of the equation. We have entered the ledger. Every rotation of the planet now includes variables that come from human choices. How much water we pump, where we build reservoirs, how we redirect rivers and drain wetlands, and reshape the distribution of mass across continents. These decisions, made for entirely practical reasons, have planetary consequences. Think about what that means. A farmer in India pumping water to grow wheat, a reservoir in China holding back a river. These actions, multiplied by billions of people over decades, have tilted the rotational axis of the entire planet. When did we become this? When did the species that once huddled around fires, watching the stars turn overhead, become a force capable of changing which stars the poles point toward? The answer is gradual. The answer is now. The answer is that we did not decide to become a geological force. We simply became one, through the accumulated weight of ordinary lives. This is not destruction in the dramatic sense. No explosions, no visible scars on the landscape visible from space. Just water, moving. Just mass, redistributing. Just the quiet physics of extraction and containment, repeated billions of times across decades, adding up to something that shifts the axis of a planet 8,000 miles wide. The rotation keeps score, and it does not care whether the force comes from molten iron churning in darkness, or from ice remembering ancient weight, or from the accumulated decisions of a species that learned to pump water from beneath its feet. All forces enter the same equation. All movements affect the same spin. We are writing entries now. Every year, every season, every aquifer that grows lighter, every reservoir that grows heavier. The planet records it all in the subtle drift of its orientation, the tiny variations in how long each day lasts, the millimeter scale wandering of the poles. The natural forces have not stopped. The core still churns, the ice still melts, and the land still rises. The atmosphere still breathes its seasonal rhythms. But layered on top of all of that, are woven into the planetary physics that have governed this world for billions of years, there is now a human signature. We are too small to notice it in our daily lives. The sun rises where we expect it. The seasons change on schedule. The stars wheel overhead in patterns our ancestors would recognize. But the instruments notice. The mathematics notice. The rotation itself notices. Humanity has become inseparable from planetary physics. Our agriculture, our engineering, our cities and farms and water systems, all of it feeds into the same equations that govern the churning of the core and the grinding of continental plates. We belong to the ledger now, and there is a mechanism that records all of this. A subtle wobble in the way Earth spins, a periodic wandering of the poles that carries the encoded signature of every force acting on the planet, natural and human alike. The next piece of the puzzle has a name, and it has been known for over a century, although only now are we beginning to understand what it reveals. All of these forces, the iron churning in darkness, the ice surrendering to warmth, the land remembering ancient weight, the water we pump from beneath our feet, the atmosphere breathing with the seasons, all of them pulling and pushing, accelerating and decelerating, writing their signatures into the spin of this planet. They converge somewhere. There is a place where all of this becomes visible, not in the length of a day, though that carries the signal too. Something more fundamental, a wobble in the way Earth turns, a slow, circular wandering of the axis itself, tracing a pattern that carries the encoded memory of every force acting on this world. It has a name, the Chandler Wobble. In 1891, an American astronomer named Seth Carlo Chandler was studying the precise position of stars. He was doing what astronomers had done for centuries, measuring and remeasuring the fixed points of the sky, looking for any variation. What he found was not in the stars. It was in the Earth beneath them. The planet was wobbling, not dramatically, not in a way anyone could feel. The axis of rotation, that invisible line running from pole to pole, was not holding perfectly still. It was tracing a slow circle, a tiny one, roughly 9 meters across at each pole. 9 meters, about 30 feet, the width of a modest house, measured at the point where the entire planet pivots. Every 14 months, the axis completes one circuit of this invisible circle. Then it begins again. It has been doing this for as long as Earth has existed in its current form. Chandler did not discover something new happening. He discovered something ancient finally becoming visible to human instruments. The wobble exists because Earth is not a perfect rigid sphere. It cannot be. It has a liquid iron ocean at its heart, and it has a mantle that flows like cold honey over millions of years. It has oceans that slosh, and ice sheets that grow and shrink, and an atmosphere that presses down with the weight of worlds. All of this mass distributed imperfectly, responding to forces that never stop changing. A perfect sphere would spin without wobbling. Earth is not perfect. Earth is alive with movement, and the wobble is the proof. For over a century, the Chandler Wobble was considered a natural phenomenon, a background oscillation, something that simply was, like the tides or the seasons. Scientists measured it, tracked it, noted its 14-month rhythm, and moved on to other questions. Then, something changed. Around the year 2000, the wobble began to slow. The amplitude decreased. The steady circle that the axis had been tracing for all of recorded measurement history began to shrink. The rhythm that had persisted for as long as anyone had been watching started to falter. And this was not supposed to happen. The wobble should be self-sustaining. The forces that drive it, the internal dynamics of a not quite rigid planet, should keep it going indefinitely. Like a top that never quite stops spinning because something keeps nudging it. The wobble should continue, but it was weakening, and no one knew why. For 2 decades, the mystery persisted. The wobble continued to shrink, its amplitude declining in ways that the old models could not explain. Yet something was changing the fundamental oscillation of the planet, and the instruments could see it happening, but the cause remained hidden. In 2021, NASA provided an answer. The wobble had not just weakened, it had shifted. The center of the oscillation, the point around which the axis traces its slow circle, had moved eastward, in a direction consistent with only one explanation: ice loss, groundwater extraction, the redistribution of mass across the surface of the planet by forces that include human activity. Think about what that means. Let it settle. A phenomenon discovered in 1891 as a natural feature of planetary rotation, something that predates human civilization by billions of years, has been measurably altered by pumping water and melting glaciers. Yes, so the wobble that Seth Carlo Chandler first detected by watching the stars has been changed by irrigation and climate, and the accumulated weight of human decisions. The length of a day is a running total, a ledger, and the Chandler Wobble is where that ledger is written. Every force acting on the planet leaves a trace in this slow, 14-month oscillation. The churning of the core tugs at the axis from below. The melting of ice redistributes weight from the poles to the oceans. Yet, the pumping of groundwater shifts mass from underground to the surface and then to the sea. The atmosphere pushes and pulls with every seasonal change. All of it writes into the wobble. All of it shapes the circle that the axis traces. The wobble is Earth's handwriting, shaky because the hand holding the pen is being pulled by molten iron below, melting ice above, shifting water on the surface, and an atmosphere that breathes with the seasons. Every tremor in that handwriting tells a story. Every variation in the amplitude, every shift in the center, every change in the rhythm carries information about what is happening to this planet. It is a seismograph written not in ink, but in the drift of an axis that the entire world turns around. And now, for the first time in human history, we can read it. Not perfectly, not completely. The signal is subtle and the noise is everywhere. But the instruments have become precise enough to distinguish the different signatures, to separate the pull of the core from the push of the ice, to identify the human entries in a ledger that has been running since the planet first took shape. We did not know we were writing in it. The farmers pumping water never imagined their actions would register in the wobble of a planet. The engineers building reservoirs never calculated the effect on axial oscillation. These were practical decisions, and made for practical reasons, with no thought of planetary dynamics. But the wobble does not care about intention. It only records force. It only measures mass in motion, and mass has been moving in new patterns, at new scales, driven by a species that became capable of reshaping the distribution of weight across continents. The wobble noticed. The wobble always notices. 14 months, 9 meters, a circle traced at the top and bottom of the world, it carrying the signature of everything that pulls and pushes on this spinning sphere, natural forces that have operated for billions of years, and now, layered among them, forces that began only decades ago. Human activity writes entries in this ledger now. Every year, every season, every decision that moves mass from one place to another. The wobble records it all in the patient drift of an axis that humanity did not create and cannot control, but has undeniably changed. And the planet keeps score, in the length of its days, in the direction of its poles, in the slow, ancient wobble that carries the truth of what is happening to this world, whether we choose to read it or not. And we are only beginning to learn how to read it. The instruments exist now, the technology to see these forces in motion, to track them in real time, to separate one signal from another in the complex symphony of planetary dynamics. Satellites orbit overhead, and measuring gravity itself, watching the mass of the planet shift beneath them. In 2002, NASA launched something extraordinary. Not a telescope, not a camera, something stranger. 2 identical spacecraft, traveling together through the darkness, their sole purpose to feel the invisible. The mission was called GRACE, Gravity Recovery and Climate Experiment. 2 satellites circling the Earth in formation, separated by exactly 220 kilometers, a fixed distance, a precise gap maintained between them as they traced their endless path around the world. The gap is everything. As the leading satellite passes over a region with slightly more mass beneath it, gravity tugs on it a little harder. It accelerates, pulling ahead by a tiny amount. The distance between the 2 spacecraft stretches. Then the trailing satellite reaches the same region, feels the same gravitational pull, and speeds up to close the gap again. So the change is measured in micrometers, millionths of a meter, fractions of a human hair. And from those minuscule variations in the space between 2 falling objects, scientists can map the entire gravitational field of the planet. It is like reading with your fingertips instead of your eyes. Think of Braille, raised dots on a page, invisible to sight, but readable through touch. The fingers move across the surface, sensing subtle variations in height, translating physical texture into meaning. The GRACE satellites do something similar. They move across the gravitational field of the Earth, feeling the subtle variations in pull, translating invisible mass into data. Every bulge of extra mass tugs a little harder. Every depression where mass is missing pulls a little less. The satellites feel it all. Ice sheets, aquifers, ocean basins filled with warm or cold water, mountains and trenches, and the slow movement of continents. And none of this is visible from orbit. A camera looking down would see clouds and coastlines, forests and cities. But the gravitational field tells a different story. It reveals what lies beneath the surface, what accumulates, what drains away. The twin satellites became a ruler, measuring the shape of something no eye can see. For 16 years, Grace circled the Earth, over 70,000 orbits, recording the tug and pull of mass beneath its path, building a picture of a planet in motion, a world where nothing stays fixed, where weight migrates from place to place in patterns both ancient and startlingly new. The mission ended in 2018, but before it fell silent, a successor was already climbing toward the sky. Grace follow on, 2 new satellites, the same elegant principle. The measurement continues. What emerged from this data changed how we understand our own world. The satellites could see ice vanishing, and not by watching it melt, but by feeling the gravitational signature weaken year after year. Where ice once pressed down with tremendous weight, the pull began to fade. The mass was leaving, flowing downhill into the sea. They could see aquifers draining, underground reservoirs that had accumulated over thousands of years, emptying in decades. Farmers in California pumping water for crops. Villages in India drawing from wells that reached deeper each season. The water rose to the surface. It evaporated into the atmosphere and eventually fell elsewhere. The satellites felt the loss. They measured the absence of mass that used to be there. Here is the surprise that emerged from this technology. We can see groundwater depletion from space. In some regions, ground-based measurements are nearly impossible. Political borders prevent access. Infrastructure does not exist. The aquifers span multiple countries with no shared monitoring. But the satellites do not care about borders. Yes, they orbit above it all, feeling the gravity of the entire planet shift beneath them. A farmer pumping water from a well in a remote valley creates no visible sign from orbit. No smoke, no light, no obvious mark on the landscape. But remove enough water from enough wells over enough years, and the gravitational signature changes. The satellites sense it. The mass is gone. The pull weakens. We are reading the planet through its gravity. Consider what this means. For most of human history, we understood our world through what we could see and touch directly. Maps drawn from coastlines and mountain peaks, rivers traced by following their paths, ice measured by landing on it, drilling into it, watching it carve into the sea. Now we feel the world from above, not with instruments that gather light, but with instruments that measure the most fundamental force in the universe, the center force that holds the moon in orbit, that keeps your feet on the ground. And that shapes the structure of galaxies, gravity. And gravity reveals everything. It cannot be hidden. Mass has weight, and weight has pull, and that pull reaches upward through the atmosphere and into the path of 2 falling satellites that notice every variation. The ocean currents show up in the data. Warm water is less dense than cold water. It takes up more space, but contains less mass per volume. When currents shift, when warm water pools in one region and cold water sinks in another, the gravitational field changes. The satellites measure it. Atmospheric pressure changes the data too. Air has weight. When high-pressure systems settle over a region, they compress the surface slightly. When they move on, the surface relaxes. The satellites sense the subtle breathing of the atmosphere pressing down on the world beneath. Everything is connected in the gravitational field. Melt ice in one place, and the water flows to the ocean, spreading across its surface and changing the distribution of mass across the entire planet. Pump water from an aquifer, and it eventually reaches the sea through rivers, through evaporation, through the endless cycling of the hydrosphere. Build a reservoir, fill it with millions of tons of water, and the gravitational field shifts in that precise location. The picture that emerges is not a static world, not a planet of fixed continents and stable coastlines. What the satellites reveal is a hyper-connected system. A world where everything that moves mass sends ripples through the gravitational field, where climate, geology, and human activity weave together into patterns that no single measurement on the surface could ever capture. 2 spacecraft, falling endlessly around the Earth, maintaining their precise formation, feeling the tug of every mountain and every melting glacier and every aquifer being pumped dry. A ruler that measures the shape of the invisible. And this is how we came to understand our planet in a new way, not just through what we can see, but through what we can feel from 200 kilometers above. The weight of ice, the absence of water, the slow migration of mass from one part of the world to another. The satellites do not interpret. They do not judge. They simply record the gravity of everything that has mass, and from that recording, we learn what is changing. Ice leaving the poles, water leaving the ground, and the ocean absorbing both, spreading the mass around its basin, raising its surface millimeter by millimeter against coastlines around the world. A dynamic planet, revealed through the most delicate measurement ever attempted from orbit. 2 objects, falling together through space, their separation changing by distances too small for the human eye to perceive, writing the story of a world that never stops shifting beneath them. Here is what we know for certain. One day, the moon will win, and it has always been winning, even now, as the Earth shifts and shudders and accelerates in ways we struggle to explain. The moon is slowly, patiently, pulling on the tides. That pull steals momentum from the spin. It has been stealing it for longer than life has existed, and it will continue stealing it long after every city on Earth has crumbled to dust. The far future is written. Days will grow longer. The rotation will slow. Eventually, in some impossibly distant era, and the Earth will turn once for every orbit the moon makes. One side of our planet will face the moon forever. The other side will never see it at all. That is the destination. It is as certain as gravity itself. But here is the problem. Between now and that far-off stillness lies chaos. The near future is not written. The near future is a tangle of competing forces, each one pushing and pulling on the spin in different directions. Some of them we understand. Some of them we are only beginning to measure. And some of them, if we are honest, remain mysterious even to the scientists who have spent their careers studying them. We built our technology on an assumption. We assumed the planet's rotation was stable, predictable, something we could set our clocks by. And in a sense, that was always true. The rotation is stable enough for daily life. You will not wake up tomorrow to find the day is 3 hours shorter. The changes happen in milliseconds, in fractions of fractions, in increments so small that no human being could ever feel them, but our machines feel them. Our satellites feel them. The networks that connect every financial transaction, every navigation system, every power grid across the globe, they feel them. They were designed for a world that turns at a steady pace. They were built on bedrock, and that bedrock turned out to be sand. Not unstable sand, not collapsing sand, just sand that shifts, sand that moves in ways we cannot always anticipate. The rotation is not a metronome, it is a living system, and living systems are unpredictable. We may need to subtract time from our clocks. This has never happened in the history of precise timekeeping. We have added time. We have inserted those extra seconds to keep our measurements aligned with the planet's true position. But subtraction is new. Yet it means the Earth has sped up enough that our clocks are running behind. And next year, we might need to add time again. That is the nature of the near future. It is weather. Not weather in the sky, but weather in the spin. We can see the general pattern. We can project the broad strokes. But the daily fluctuations will surprise us. A shift in the core, a pulse of meltwater entering the ocean, a change in the atmospheric rivers that circle the poles. Each one nudges the rotation in ways that ripple through our instruments. The models are good. They are the best we have ever built, but they are models of a system with hidden variables. Variables we cannot directly observe. Variables buried under thousands of miles of rock and iron, or locked in ice sheets that are changing faster than we can measure them. We have sent robots to Mars. We have photographed its surface in detail that would let you count pebbles. We have mapped its craters and valleys and ancient riverbeds with precision that would satisfy any cartographer. But if you ask what those continent-sized structures at the base of our own mantle are made of, the honest answer is, we are not entirely sure. It is a little embarrassing when you think about it. Mars is millions of miles away. The base of the mantle is right beneath our feet, and yet Mars is easier to study. Its secrets sit on the surface, waiting for our cameras. Earth's secrets are buried in crushing darkness, shielded by pressures no instrument can survive, hidden in a realm we will never visit. This is the humbling truth. We have mapped another world more completely than the interior of our own, and so we predict with uncertainty. But we forecast the spin, the way we forecast hurricanes. We see the forces gathering. We measure their strength. We run simulations that show a range of possible outcomes. But the exact path, the precise timing, the specific moment when one force will overpower another, that remains beyond our grasp. The moon will win. That is the long game. The tides will drain momentum from the spin until the rotation locks into place. But between now and then, and in the years and decades that matter to you and everyone you know, the planet is a competition, a conversation, a negotiation between forces that do not care what we find convenient. The core pulls one way, the melting ice pulls another. The atmosphere breathes in and out with the seasons, adding its own rhythm to the chaos. And underneath it all, the ancient memory of vanished glaciers is still reshaping the crust, still pulling mass back toward the poles as the land slowly rises. The planet we depend on is not stable. It was never stable. It only seemed that way because our instruments were too crude to notice the fluctuations. Now that we can see them, we must adapt. Our timing systems will need to become more flexible. Our networks will need to tolerate small adjustments. The infrastructure we built for a clockwork planet will need to learn to live on a planet that breathes. This is not a crisis. It is a reckoning. A moment when our technology finally became precise enough to reveal what was always true. The Earth is not a machine. It has never been a machine. It is a world in constant motion, adjusting itself moment by moment, responding to forces that stretch from the liquid iron at its heart to the thin shell of gas we call the sky. Uncertainty is not a flaw in our understanding. It is a feature of the system we are trying to understand. The planet keeps its own time, and we are simply learning to listen more carefully. The machine in the basement laboratory in Boulder, Colorado, does not know any of this. It does not know about the liquid iron ocean churning beneath the surface. It does not know about the solid sphere at the center that may be drifting in a direction no one expected. It does not know about ancient continents of ice vanishing into warming seas, or bedrock remembering the weight of glaciers that disappeared before anyone carved the first letter into stone. It does not know about farmers pulling water from the ground. It does not know about rivers stopped by concrete. It does not know about invisible highways of wind circling the planet, carrying the weight of an atmosphere heavier than anything humans have ever built. The machine knows nothing about any of this. It only counts. Over 9 billion oscillations. Every single second. A rhythm so precise that the machine will not lose track for longer than the dinosaurs walked the earth. And in that count, in those vibrations too fast for any human sense to register, it records everything, every force, every push, every pull. The machine is not measuring time. It is taking a pulse. Picture a doctor pressing fingers to a wrist. The heartbeat carries information, not just rhythm, but health, not just speed, but strain. The pattern reveals what words cannot. And this machine, counting cesium vibrations in a temperature-controlled room, is doing the same thing to a planet. Every rotation is a heartbeat, and the machine feels each one. It felt the shortest heartbeat ever recorded. It felt the years when the planet raced faster than any year before. It felt the subtle signature of forces wrestling beneath the crust and above the clouds. It recorded them all without understanding any of them. And that is what a witness does. The length of a day is a running total, a ledger. And now you know what gets written there. Iron moving in darkness, ice sliding into oceans, land rising from sleep, air pressing against the spin, Water pumped from one place and pooled in another. All of it, every force, every shift, every invisible transaction between one part of the planet and another enters the ledger, and you are living inside one of its entries. A single rotation, one day, one heartbeat of a world that has been spinning since a collision so violent it created the moon. A world that will keep spinning long after every clock has fallen silent. Every city has crumbled. Every trace of this civilization has been erased by weather and time. There is no problem here. That is the quiet truth this journey reveals. The title asked what is wrong with Earth. The answer is nothing. Nothing is wrong. There is only a planet doing what planets do, responding, adjusting, breathing in its own slow way. The something wrong was never a malfunction. It was movement. It was life. It was a world that refuses to hold still because holding still was never an option. The core shifts, the ice melts, the land rises, the atmosphere wanders. The water moves from aquifer to ocean to sky, and through all of it, the spin continues. Faster some years, slower others, never quite the same twice. The machine in Boulder keeps counting. It will count tomorrow, and it will count next year. It will count when you are gone, and when your grandchildren are gone, and when no one remembers that anyone was ever here to wonder what a day meant. And in that count, the planet's heartbeat will continue. You are part of this now, not separate from it, not watching from outside. Every breath you take slightly shifts the atmosphere. Every step you walk slightly adjusts the crust beneath your feet. You are a passenger on a spinning world, yes, but you are also part of what makes it spin the way it does. The ledger records you too, somewhere in the numbers, in the oscillations, in the atomic precision of a machine that will never sleep. There is a trace of this moment, this rotation, this day. The planet keeps its own time. It always has. And tonight, as you drift towards sleep, the machine keeps counting. 9 billion vibrations, then 9 billion more, patient, precise, taking the pulse of a living world that has been spinning for 4.5 billion years and shows no sign of stopping. Close your eyes. The Earth is still turning.